Good afternoon, ladies and gentlemen. Welcome to this webinar. My name is Alexey Laureshin. I am a researcher, teacher at Lund University in Sweden. But today I'm wearing a different hat. I'm also the editor of the Traffic Safety Research Journal. And we continue our series of webinars about how to conduct and publish excellent research in traffic safety. And today we have very excited, very senior, well-seasoned speaker, Oliver Carsten, a professor in transportation safety from University of Leeds in the United Kingdom. Oliver has been around for quite some years. He's been doing research on driver interaction, on driver assistance systems in vehicles. He was one of the pioneers running pilots with intelligent speed adaptation systems. And today also he is quite actively involved in regulatory work, helping the lawmakers to create rules for autonomous vehicles that are coming. So we should be prepared for them and make rules that make sense. And also Oliver knows a bit about the publishing business because he is one of the editors-in-chief for the journal called, let me see, Cognition, Technology and Work. Yeah, so the setup is quite usual. I hope by now you know the drill. There would be a talk given by Oliver, and at the end, we will have some time reserved for questions and answers. And we are just in one big Zoom meeting, so anyone can unmute herself and speak. But to get some order into that, I would ask you just write your name in the chat, and I will call you out in the order that the names are appearing. Yes, so I suggest now that I give the floor to Oliver. You are most welcome.
Well, thank you for that introduction. It was very nice. I indeed can't talk about my whole career. That would bore you for about 4 or 5 hours. So what I've decided to do is to first of all, to tell a few anecdotes, especially from my career as a young researcher. I learned a lot in my first 3-4 years of doing research in traffic safety and road safety. So that's where I'm going to start. And there we go. So the first big report I was involved in, you can see it on the screen, August 1981. So just by way of personal background to that, in 1977, I was a PhD student, actually not in anything to do with traffic, in US social history at the University of Michigan. I was embarking on writing my thesis, but I hadn't run out of fellowship money. So I needed a job. So I saw a job advertised at what was then the Highway Safety Research Institute, HSRI. Now it's called the University of Michigan Transportation Research Institute. And I had an interview and I was hired. I don't even know how many other candidates there were. Maybe there were none. And the reason they hired me because I actually knew something about statistics and I had taken a couple of courses in statistical analysis and so on. So the first big study I worked on was this fleet accident evaluation of Federal Motor Vehicle Safety Standard number 121. and 121 was anti-lock brakes on air-braked trucks. So it was basically about the requirement to fit anti-lock systems on large trucks in the US. How did we do the study? We got data on exposure of vehicles from actually a national sample of vehicles. We had access to the national registration data, which we bought. And then we had crash data, both fatal data and reported injury data. So truck companies were required, obviously, fatal data was easy to identify. There was a national fatal crash accident reporting system, FARS, still in existence. But the Bureau of Motor Carrier Safety also required truck companies to report their less severe crashes when they happened. So we looked at basically vehicles that were manufactured before or sold before the regulation came into being, and those sold afterwards. That was the comparison, the baseline comparison. So it was a really big study. I don't remember how many millions of dollars it cost. And it was almost the first, if you like it, it's very similar to a field operational test, but we weren't observing the drivers, we were just collecting crash data. And it was almost that, again, I think it was a pioneer in that this was the first safety evaluation where the agency, National Highway Traffic Safety Administration, decided they wanted to know if it actually worked, if it was successful. So we published the study, but we came up with the wrong answer. So those are the people, that's me talking to my co-author, Ken Campbell. I found that picture in an annual report from HSRI. I don't know what we're conspiring there, but it's about something. We talked quite a lot, as you can imagine. And that picture, I don't know if anybody recognizes her, that is Joan Claybrook, who was then the director of the National Highway Traffic Safety Administration. So she was essentially one of Ralph Nader's group. Ralph Nader wrote a famous book, Unsafe at Any Speed. That was an indictment of General Motors for their lack of providing safety features. And he also in that book, he expressed advocacy of a kind of safe system approach, that we should make the vehicle safe, not rely on just targeting human error in crashes. Joan Claybrook sorry, I'll go back to Ralph Nader. Ralph Nader, actually, that book caused such a stir that it led to the inauguration of the National Highway Traffic Safety Administration, hearings in the Senate on traffic safety, et cetera, et cetera. So it was a huge bestseller and it caused a big storm. It was actually Bill Haddon Jr., who you've also probably heard of, who was the first director of NHTSA, the one responsible for the Haddon matrix, et cetera, but Joan Claybrook succeeded him. And she told the university, well, obviously we sent the report to her, and what we found was that there was no benefit of the system. And in fact, there were indications that it was harmful, that there were more crashes with the vehicles equipped with the safety system than not equipped. So you might ask, how was that even possible? Well, one thing was that technology was just taken off airplanes and transferred to trucks. So airplanes get serviced every time they land or whatever, somebody checks. Typical US truck got serviced every 160,000 kilometers. So the systems weren't reliable. They were subject to moisture ingress. They were subject to interference from CB radios. when there was a warning light on the truck dashboard that indicated when the system was faulty, the drivers got so fed up with the warnings, they just covered the warning light with masking tape and ignored it. Another thing is that the regulation didn't incorporate proportioning systems. If you know a little about truck braking, you need to know that if you have an empty trailer, you have a tendency to over-aggressive braking. So you need to adjust the braking force to take care of empty versus loaded trucks. That wasn't in the regulation. And the test for the regulation was just stopping in a straight line. That's quite easy, but stopping in a curve would have been a much tougher test. So there were loads of problems with the way the regulation was set up. Of course, we didn't know all of that when we embarked on the study, but we heard all these stories about the problems. So we reported this to Joan Claybrook and her agency. We reported that there was no indication of any statistical benefit, and there was some indication of a disbenefit. And she told the University of Michigan and Highway Safety Research Institute that if we published that report, she would make sure that we never got any federal transport funding again. So that was quite a threat. And this gentleman, Robert Hess, was the director of HSRI. And in the contract, we had the right to publish the study after 1 year, regardless of whether the federal government approved it or not. So that was a contract provision. So August 1981 was actually a year after we delivered the study. And in August 1981, Robert Hess said, go ahead and publish. What happened? Well, indeed, the money got cut off. But it only got cut off as long as Joan Claybrook was director of NHTSA. And she didn't last very long. I can't remember who replaced her. She was replaced quite soon afterwards. And all the officials in NHTSA knew essentially that what we said was true, that we had done a really good job on the evaluation. It was very thorough, it was properly conducted, and if the findings were negative for the system, so be it. And anyway, eventually the Supreme Court threw out the regulation. I don't even remember why that was. So there's a lesson there, and I'll come back to that. In 1983, we got I think it was then already the University of Michigan Transportation Research Institute, got a contract from National Highway Traffic Safety Administration to design a test dummy with greater biofidelity. That means faithfulness to the human body, behaving more realistically in a crash, not just, for example, dealing maybe with frontal crashes, etc., etc. And the job I had in that study was to advise on where they should focus. Which part of the body do you focus on? I mean, do you make really good fingers or toes? Do you make a really good heel or whatever? And so I plan to use a mashup of injury data with long-term impairment ratings from surgeons. So the injury data I got from a predecessor of NASH. It was of NAS, the National Accident Sampling System. It was called the National Crash Severity Study, that precursor, and it had all the injury coding and a load of in-depth information about the crash. So you could relate the injuries to the crash vectors, to the vehicles, to whether the vehicle rolled over, etc., etc. And then we got ratings from surgeons about how much long-term impairment a given injury code, so we had the occupant injury classification codes, how much impairment would result from such an injury over 1 year, 2 years, or maybe even somebody's lifetime. So you probably know about the AIS scale, the Accident Injury Severity Scale. That models threat to life, what the risk of a fatality is. We wanted to know what the risk of long-term impairment was, and AIS doesn't do a very good job on that. And then I combined that with ages of people, because obviously you don't want to say somebody has impairment for 50 years. If they're 90 years old, they're not going to survive until they're 140, and so on. So we had a meeting with NHTSA in 1983 at the beginning of the study. And Rolf Eppinger was one of the people present. He was the kind of the lead spokesperson, even though he wasn't the project officer. And he is or was a very well-known injury researcher. He was working in the federal government, but he was definitely an expert. And then Mark Hafner, who was the project officer, was junior to Rolf Eppinger, and he was also in the room. And the other people in the room were John Melvin, the head of the biosciences unit at Umtree, and Jim O'Day, who was head of what was called the system analysis group at Umtree. And that group was the group I was in. So it was the group that, for example, did crash analysis. And what happened? So Rolf Eppinger came in essentially with whole sheets of paper about how I should report all my results. These are the graphs you should use. You should graph this against that and this against that. And he had dozens and dozens of graphs that he proposed, which, to my view, nobody would even have been able to integrate and think about as being very useful. And I said, no, I'm not going to do any of that. I'm going to deliver something far better than that, this integrated analysis that I just talked about, with essentially ratings of each crash about what the harm caused by that crash to a given occupant or even all the occupants in a vehicle was. And Rolf Eppinger, I tried to colorize the picture, but I couldn't really do that very well. He just went redder and redder and redder as this junior researcher was arguing with him. I mean, it looked like he was going to have a heart attack. But then they left, the meeting ended. And I said to John Melvin, why on earth did you let me get away with that? Why didn't you intervene to try and smooth things over? And he said, well, because your boss, Jim O'Day, didn't say anything. So I thought it was all okay. And I told him, well, Jim O'Day was just scared shitless, if I can use that expression. He was too frightened at this argument to intervene. But subsequently, I delivered essentially a report. These are two tables from the report. And you can see, for example, that by body region, head, face, and neck together accounted to 60% of the harm, total harm to occupants in all the crashes. So I summed across, of course, all the crashes over the 3 years or whatever it was of crash data I was using. And you can also see on the other side that the frontal crashes were more harmful than other crashes, etc. So that said, don't work on the knee, 1.6, don't work even less on the ankle foot, 0.6%, less, half a percent. Really, really, really focus on the spine and how the head behaves and how the neck behaves, etc. in a crash. So one of the things, for example, that the surgeons told us was that an AIS-1, low severity injury to the head, might cause people headaches for 5 years after the crash. Really, really severe headaches. So that was really interesting. No, not very much threat to life, but horrible threat to enjoying a productive life. And the ironic part was that NHTSA was really, really pleased with my report. They loved it. They even asked me to send all the code and all the data, to compile this rating back to them so they could use it themselves for their own internal work. So that was another interesting lesson for a young researcher. So now I'll move on. In the late 1980s, I moved to the UK, and I started work quite soon. We got a driving simulator, and we got a project called external vehicle speed control. So that was the idea that every time there was a change in speed limit, you'd have a transmitter on the signpost that would transmit the new speed limit to vehicles passing it. Of course, a big problem with that is you have to know the direction the vehicle is going, because some vehicles are going to the higher speed limit and some are going to the lower speed limit. But be that as it may, that was the concept. Very soon, actually, we hit on the idea, well, why do this? We can use GPS and a map, a navigation map encoded with speed limits to do that far more effectively. And we actually learned that the Swedish researchers had arrived at exactly the same conclusion almost at the same time. So we couldn't patent that idea and get rich. It was basically almost an obvious idea. But on the 22nd of January 1999, we gave a briefing on the results of the external vehicle speed control to the then Minister for Roads. That's a junior minister in the Transport Department, who was Lord Larry Whitty. Now, Lord sounds very posh. He wasn't posh at all. He was a former trade union leader. And he liked being called by his first name, even by me as a researcher. So he was Larry. And he was actually probably the best minister with responsibility for road safety that Britain has ever had. So he essentially put together this road safety strategy with targets. It was the second road safety strategy in the UK for Great Britain, with targets for 2010, very substantial targets. But alongside that, he did this report called New Directions in Speed Management. And that report really looked at how speed was a big problem in managing road safety. Again, you'll probably know that speed is one of the pillars of the safe system. And he, if you like, or his officials who talked to him, but he accepted it, was one of the first people to accept that contention, that we had to move to a regime in which we manage speed top down. And in that briefing, we got a really good part of a day with him. That's quite unusual, actually, that a research project, even one funded by the ministry, would get a lot of time with a minister. Most ministers don't care at all about the research. They're going to move on to a better job, they hope. I've seen many ministers who open conferences and then after 5 minutes sneak out or say they've got some other engagement and they'd never hear what the conference is about, etc. But Larry Whitty was really committed to road safety. And actually, he still is. He's still active. In December 1999, we had him again. We did a demonstration of our external vehicle speed control, or ISA vehicle. It was a modified Ford Escort on a circuit near London. And we devised basically a test circuit. We did it on the fly. We devised a test circuit with pretty much every UK speed limit on it. So it was pretty nice. And you could drive around that in about an hour. And he was impressed. Did he remember? So in 2008, we presented a report, Speed Limit Adherence and its Effect on Road Safety and Climate Change, to an advisory group to the ministry, the Motorists Forum. So it was basically an extension. It was a more in-depth analysis of the data that we'd collected in our ISA study, plus some focus group data, plus some survey data. And we also looked at how the speed trajectories of the ISA vehicles compared with the non-ISA vehicles affected emissions. So we could look at fuel consumption and carbon effect of intelligent speed assistance. And Larry Whitty was there as one of the members of the Motorist Forum because he was chairing a consumer group called Consumer Focus. And what he said was to Patricia Hayes, the person in that picture on the right, the head of the roads division in the Department for Transport, he said, "I remember Oliver's car. It was great. You should implement ISA right away." And she just went white. That's what my recollection of the meeting. She just didn't think that the current ministers would even give a minute's consideration to such an idea. But anyway, it couldn't have happened because the UK didn't have jurisdiction over safety standards for new vehicles. We were a member of the EU, and that was part of that right to legislate safety standards for vehicles was delegated, if you like, to the EU. It was an EU decision on which safety systems should be fitted. So on intelligent speed assistance, nothing happened. There was actually one Dutch researcher, I'd like to find out who it was, who said it was the best system we never had. So, i.e., that was before the EU actually went with it. So I'm going to talk a little bit about that. So ISA came back from the dead. How did it come back from the dead? Well, DG GROW is it's the industry ministry in the EU that's responsible for vehicle safety. Rather odd. DG MOVE, which has general responsibility for road safety, is only there, I guess, as an advisor to DG GROW. So DG GROW conducts the study. DG GROW decided in around 2014 to implement a study to investigate how the basic safety requirements on all new vehicles sold in the EU, i.e. the general safety regulation, should be revised to incorporate crash avoidance technologies to supplement existing crash mitigation technologies. So most of the previous regulations were all about occupant protection. There was a big battle about pedestrian protection. Actually, that battle was lost by the safety community. So it was really all about seatbelts, crumple zones, airbags, all that stuff. But DG GROW, or the people in DG GROW, realized that all this electronic technology now offered a chance of designing systems that could prevent crashes from occurring or mitigate their effects if they did occur by, for example, braking before the crash happened and so on. So UK TRL was hired to do that study, and the first report came out in 2015. You can find this report on the internet. It's quite a mouthful, the title. It's the longest title. I think it should get the award for the longest title in road safety. Benefit and feasibility of a range of new technologies and unregulated measures in the fields of occupant protection, safety, and protection of vulnerable road users. So, conclusion was, based on the evidence reviewed, the following measures were considered to be likely to be cost beneficial and could, on that basis, be taken into consideration. Enhanced advanced emergency braking with collision mitigation, intelligent speed adaptation, which was the earlier name for intelligent speed assistance, lane keeping assist, reversing detection and reversing camera systems, and emergency brake light display. Emergency brake light display just tells the following driver that the vehicle is braking very, very sharply. So how did they do this study? They did it on the basis of literature review. And they cited our studies on ISA, I can't remember how many times, a couple of dozen times in the report. So that was a substantial contribution because I'm not trying to denigrate the Swedish studies or the French study, etc., or even the Dutch work. but we had probably done the most thorough work on looking at looking at the effects on urban roads, rural roads, motorways of widely deployed intelligent speed assistance with essentially an overridable assisting system. And we had concluded that there were very, very large safety benefits to it. We'd done a cost-benefit study showing roughly 6-to-1 cost-benefit to cost-benefit ratio or benefit-to-cost ratio. So the benefits vastly outweighed the costs, and we were incredibly conservative on the costs. We estimated that the cost of ISA would be about 40% of the cost of the new vehicle, which of course is far from the truth in mass production. So the GSR report had this traffic light system. They rated various safety systems, safety technologies. Green means go ahead with them. Amber, yeah, maybe go ahead with them. Or red, no justification. So you can see that ISA actually came out number one in that benefit to cost ratio. Benefit to cost ratio greater than 1 for 6 member states for voluntary activation, switched on off by the driver, and mandatory activation. Public acceptability considered to be growing. BCR higher for mandatory activation, but both have positive BCR. So that was, I mean, I'll come a bit later to the various forms of ISA, but you can see AEB was benefits roughly equal to the cost. We were benefits greater than the cost. So number one among the systems that TRL looked at. And there was a series of subsequent reports that went into greater and greater detail about what they should do, but essentially came up with the recommendation. And in 2019, as you may know, GSR2, that's the second wave of the general safety regulation, was passed, and vehicles from 22, 23 have to have ISA on them. So this is a report from one of our national newspapers. You might call it a trash paper. End of speeding. Package of safety systems to be fitted on all new vehicles sold across Europe. And so the systems included intelligent speed assistance, advanced AEB, lane keeping assistance, vulnerable road user detection and warning for front and side on large vehicles, better pedestrian detection. It wasn't true that they came into force in 2021, 22, but that doesn't matter. So actually there was quite a lot of positive publicity, in spite of the fact that all the tabloid press, the popular press, previously had said how intelligent speed assistance is just an awful system and which no motorist will like. So what form of ISA should the EU go with? DG GROW could not copy, as it often did for vehicle regulations, an international specification from UNECE, the body that sits in Geneva, Road Forum for Harmonization of Vehicle Regulation, International Vehicle Regulations. So it had to prepare its own text. And that's called a delegated act. It's basically a piece of legislation in Brussels. And the final delegated act has to be approved by, I guess it's proposed by the Commission, but Parliament and the member states have to approve it. Industry pushed very, very hard for an alternative to the assisting system, which basically the assisting system works on ISA by limiting your acceleration beyond the speed limit. You can't accelerate beyond the speed limit unless you kick down to deliberately request to speed. So the driver's still able to speed, but they're strongly, strongly discouraged to do it by that HMI, by that interface. Industry wanted a beep system, a system that basically beeps at the driver every time they go maybe 3 or 4 kilometers over the speed limit. Why did they want it? Well, one could argue mainly because it was cheaper, but I also have the thought, and other people haven't disputed it, that industry actually wanted motorists to protest that they got really annoyed about the system and then thereby get any legislation withdrawn after it first came into force. So we carried out a simulator study for European Transport Safety Council to look at various forms of interface with ISA. This was before the final decision on the delegated act. So some of you know ETSC, it's a very strong advocate for road safety, operating in Brussels. I've had very good relations with them. I think they do a terrific job of making sure that people focus on safety potential of technologies and on the safety problems that vehicles may cause and do cause. So we carried out this study, as I said, and this is the one place I'm going to show you some actual results. So this is the 50-kilometer-an-hour roads. So everybody did a baseline drive, and then they drove with one of those 5 systems shown in blue in counterbalanced order. So they didn't drive all in the same sequence, but the baseline drive was always done first. So they had an auditory warning, the beep system. They had a haptic pedal, which was essentially a pedal force that would try and prevent them pushing down, because you get a counter force, a vibrating pedal that would just vibrate with a vibration motor on them if they tried to exceed the speed limit, speed control with a vibrating pedal, and speed control alone, which was the system of ISA that we and the French studies had pretty much tested in the real world. So, sorry, yeah, you could see in that there wasn't really much difference between any of the systems. And here's the 60-mile-an-hour roads, our rural roads, 96 kilometers an hour. We have a really high speed limit on rural roads. And again, not much difference with the system. And strangely, not much difference from the baseline. But that was maybe to do with being in a simulator, although there isn't that much actual speeding on these roads, because they're usually the road design, the curvature just stops you from speeding, or you're in heavy traffic following another vehicle that's going quite slowly. 70 miles an hour, this is our motorways, 112 kilometers an hour, pretty much the same pattern. No difference, no substantial difference between the systems. But we did an annoyance study, and we asked people about how pleasant or annoying from -5 to +5, it was -50 to +50 on this, on a continuous scale. We asked them how annoying or pleasant a system was. And there's nothing very new about this. I guess people had used Likert scales in the past, where you rate it from not annoying 0 to 5 very annoying or whatever. We decided to use a continuous scale just because it would be more sensitive to differences between the system. But the one innovation we had was we asked how annoying would it be if you had a passenger in the vehicle with you, with the hypothesis that the beep would be really annoying, or much more annoying, to drivers who had a passenger, because they would hear the vehicle beeping at the driver and telling them off, telling them you're doing something wrong. And therefore, they would, that would not be a very pleasant experience for the driver to know that the passenger was hearing that same message. And as you can see, the auditory warning was one of the more annoying systems, but there was a huge increase. This is down here, in the annoyance factor for hypothetically driving with a passenger. Conclusion. These findings would suggest that neither the auditory warning nor the vibrating pedal without speed control are good choices for ISA HMI. So what did the EU do? Unfortunately, the project officer looked at the speed and says, the speed results, and says, well, it doesn't make much difference, so we might as well have the beep system. Our argument, of course, was that the beep system would be one that would encourage drivers just to switch it off, because there's an off button on the ISA system that you can switch off during a journey. At the next ignition on, the system comes on, but then, of course, you can switch it on again and so on. So, as I said, DG Grow interpreted the findings as showing little difference in effectiveness, and they didn't incorporate the likely effects of drivers switching off an annoying system. And now they're getting loads of complaints from motorists about the beep system. Indeed, they're getting loads of complaints from motorists that they have several systems that all beep at them: the forward collision warning, the lane departure warning, the ISA system, and how are motorists to know which system is beeping at them? But that's a problem for another day. So this is pretty much my last slide. As Alexei said in his introduction, one of my major activities now is participating in UNEC work on vehicle regulations. So this is a picture that my colleague Frank Mutzi from ETSC took at one of the GRVA meetings in Brussels. GRVA is the group on vehicle automation. It's the group above all the working groups writing specific regulations on specific systems. And what you can see there at the front in blue is all the member states, the contracting parties. And the EU is actually, in addition to its own member states, the EU is, or the European Commission, is another member state in that meeting. What you can see behind next in purple is all the industry representatives, almost equal numbers, if not larger numbers, than the contracting parties. Now, industry doesn't vote, but industry gets a voice, and they have a designated spokesperson on every problem. And why do they all come? Well, maybe it's just to keep an eye on the spokesperson to make sure they're saying what was previously agreed. And they speak with consensus. So in UNECE terms, it's OICA, the International Vehicle Constructors, and CLEPA, who are the tier one suppliers, who basically meet, and they meet each evening during meetings as well. They prepare their opinions, they prepare texts, and they push very hard for those texts to be incorporated. Over in orange, you can see some of the international organizations relevant, like the International Telecommunications Union, etc., that also have the right to participate. And finally, in green, you can see the very few members from civil society. So Frank has actually pointed out where he was seated in that meeting. Civil society organizations, for example, Transport and Environment, ETSC, are recognized by UNECE or recognized by the UN in Geneva and have the right to attend meetings and speak, but of course not the right to vote. As I said, only contracting parties can vote. So here are my conclusions. Don't be afraid to speak up. That was a lesson that I learned very soon in my career. You don't always get what you want. Well, yeah, there are compromises you need to make. And I guess on ISA, that was maybe unfortunate. We'll see when the ISA regulation comes to be revised, whether the DG Grow is so inundated with complaints about it and so inundated with industry pressure about the overburden that they have from regulation to take it off, or they decide to actually do what they should have done in the first place and not allow the beep system. Maybe even a partial victory is worthwhile. That's, I guess, another big lesson. Luck can play a substantial role. So that was essentially it was lucky that, if you like, or maybe it was foresight by DG Grow, to realize that systems like ISA had the potential to be really, really productive in crash and injury prevention. And now it is possible and valuable to participate directly in the policy domain. And I think that's something that researchers are very loath to do. They would rather hide in their ivory towers, maybe write more journal papers and not actively advocate for what they've learned from their research, or even use their skills and knowledge to say, well, this proposal just doesn't make sense based on first principles. And we can't research everything. So in the area of regulation on automated driving systems, we just have to use first principles sometimes. Say, well, you know, these are obvious user needs. These are the ones we need to cater to, and so on. And I think that's my last statement. So thank you very much for your attention.
Thank you very much, Oliver. Yeah, so again, I remind you, the audience, if you want to ask a question, just write down your name in the chat. Okay, Mats, okay. Jump in.
Hi, Oliver. I don't know if you remember me.
I do.
Oh, fantastic. Now, first of all, thank you very much for this history. You know, I've been involved in road safety for a very long time now. I started already at the Swedish Traffic Safety Agency in 1990. So I'm aware of some of the challenge the road safety community have had when it comes to road safety. And for me, coming and being deeply involved in this Vision Zero kind of movement in Sweden, I was really surprised actually in that time that the politicians and others, they adopted this very, very bold policy like to eliminate fatalities and serious injuries. And that was fantastic, you know. But then when you start to implement things, you get into a problem,
resistance.
So, yeah, exactly. But I wanted to ask you a little bit about this. Well, there were so many interesting things that you talked about today, you know. But if we can talk a little bit about this ESA system, and as you know, I'm now working for WHO in Geneva, so my work field is broader than Sweden and Europe. Now I have the whole world, and 90% of all fatalities is happening in the low and middle income countries. Mm-hmm. So we hope that there is an opportunity for leapfrogging and so on. But my experience with this ISA in Sweden, because I was deeply involved in this large-scale demonstration project, more from a policy perspective and the relation to politicians and others. There were a sense of big brother, you know, coming in with this new technology now, and it was like George Orwell or whatever, you know, start to manage things, you know. And I'm wondering just from your side, how you see this and how it have played out, because now we talking about regulation, that sort of thing, and that was, at least from the Swedish perspective in the late 90s, that was not on the agenda at all. It was more voluntary and that sort of thing. But what do you think, and why take it so long time, you know?
I think eventually the time was right, but also the technology was right. It became easier and easier to buy a camera system that could detect speed signs. You can't argue any longer that that's expensive. The camera costs maybe 30 euros, so you have to program it, big deal. We need to supplement the camera with the map. But again, there's still some problems with keeping those maps up to date. But of course, in essence, the camera and the map could report back to the map maker where there are problems or where there's no consistency. So we reached a time when electronic ISA would become reliable, fairly cheap, and I guess at the EU level, industry actually, of all the measures, the only one that industry objected to of the whole package of measures was ISA. So we had to go to European Parliament and say why it was important. The rapporteurs from European Parliament had to tell the Commission that it was important. So there was a lot of lobbying going on, both pro-ISA and against ISA. And ETSE was really, really helpful in all of that. So you need a safety lobby. I mean, that's a pro-safety lobby. You can't just trust that politicians will do the right thing. You're right. So one of the things, obviously, you could do with ISA, you could record in the vehicle every time drivers went over the speed limit. That would be fairly easy to implement. You could even have automatic fines. The recording just sent back you got a speeding ticket every time, automatically every time. That would not get public acceptance because there would be a spy in the vehicle system. The other thing about that is that people also had this idea that the GPS satellites were spying on the individual vehicles. We had this, even the BBC did a picture with spy in the sky satellites as sort of part of the ISA configuration, instead of saying, actually, no, it's the vehicle spying on the satellites just to get their position. That's all those satellites are providing. So you have to explain the technology. But there hasn't ever been a lot of public resistance. All the survey work that's been done on ISA, both by ourselves and by survey people, has indicated that the public wants speed compliance and is willing to accept ISA. So it hasn't been a huge push to get public acceptance. Some newspapers, particularly in the UK, there's a very strong, if you like, conservative or right-wing press. They like stirring up trouble, and they always wrote negative stories. I even had interviews with journalists where they would say, oh, I really like your ideas and I like your system. Don't be surprised if the front page of our newspaper tomorrow comes out with something saying the opposite, because that's what the editor wants. So you have to be prepared to argue your corner. But that's, in my view, only, at least in most of Western Europe, only a minority view. Public wants people to obey the driving rules. They want people to be protected by rule-abiding drivers. I don't know if that answers your question.
No, thanks. That's great. Thank you.
Okay, great. Thank you. Rula, you can take over.
Hey, thank you. Hi, everyone, and hello, Dr. Carsten. Thank you for your great talk. It was really inspiring. Just a bit of background on myself. I study road user behavior using quantum mechanics inspired models, hybrid discrete choice, and machine learning models.
Mm-hmm.
And I also use virtual reality experiments equipped with neurophysiological sensors for brain wave and GSR. So my question is, do you see a future where models of a driver mental state that captures, for example, shifts in neutral, defensive, or aggressive driving that could be used to assess the how drivers interact with L2 and L3 systems?
Okay, we actually had this discussion the last couple of days in a project meeting, exactly that issue. Can you put a virtual driver in the loop interacting with systems and then vary their personality, etc.? I guess I'm very, very skeptical that we can do that in any reliable way. I think it sort of violates fundamental issues about human-centered design and so on, that we should have qualitative discussions with human participants before we even embark on designing systems. Those same human drivers should be part of the evaluation. So maybe in the future we can just use AI bots or whatever to interact, but I don't think we're ready yet. I don't think we can capture the full range of human performance with that. We can capture all the driver impairments that people have, whether they're permanent disabilities or temporary impairments from drink, drugs, mood, fatigue, whatever. I don't think we're ready yet to do that. And I don't, if that was the wrong answer, I'm sorry.
No, that's all. Thank you so much. Just like I have two other follow-up questions. First one is, what do you think are the human automation failure patterns are still missing from simulator or VR experiments?
Well, it's how what we don't know yet is how a level 3 transition will take place in the real world. So manufacturers have done experiments, of course. They've probably driven with their own recruits on the system. But again, you know, they haven't subjected people to driving 18 hours or whatever they do with a vehicle and then seeing whether they can remain attentive to requests from the level 3 automation system to take over. We're now discussing hands-off assistance system. I'm a steadfast opponent of hands-off driving with assistance because I think that takes drivers out of the loop, puts them in supervisory control, and means that they're not actively engaged in vehicle control, and that's highly risky. And then drivers will treat that hands-off, feet-off system as being automated when it's not, when they're still responsible for safety. So it's kind of a con job by the car industry. I'll produce a system that, you know, looks like automation, behaves like automation, but still leaves you responsible if there's a crash. And that's maybe very nice for them, but not very nice for the user or for safety.
Thank you so much. My last question is, how do you currently view surrogate safety measures when evaluating driver automation interaction? How is it like? How important is it to you?
That's very important. I mean, that's the main area I've been focusing on in EU regulation, UNECE, UN international regulation on automated driving systems. So I was the co-chair of the group on user interaction there. So we've tried to put in requirements that will force the manufacturers at least to pay attention. But at the moment, those requirements are very, very generic. So they say you need to consider this and you need to consider that. We don't, by any means, yet have pass-fail criteria that a type approval authority can use. And that's going to be further work.
Thank you so much.
Thank you. We're kind of running out of time. So Lars, you probably will be the last question. Lars?
Yeah, thanks ever so much. Thanks, Oliver. It's so nice to hear you, and I have to thank you for you being a tutor in my career as well. So, but I was noticed that you raised up an issue which I think is very important. The loud minority in comparison to the majority that actually wants safety.
Yep.
We had the example when we should introduce roundabouts in Sweden. We did a very good study in the city of Växjö, and it was virtually one person that managed the rumor and the information about that, and that was a journalist at the local newspaper. He managed to get the whole country to realize that roundabouts was really crap. Until we did a proper study and stating that people really wanted roundabouts, so I think that's quite a common issue, because I think what the journalist didn't like was the Lund University playing with their his city. He didn't like that, but the people really liked the roundabouts, and the politicians actually were brave enough to continue for a year until we did the proper evaluation. But I think this issue with the loud minority for on very loose grounds, we have seen that on mid barriers from the motorcycle lobby and things like that. I think that is there good ways to conduct research on that?
Yeah, I don't think, I'm not aware of any research. I mean, we get that loud minority on loads of social issues, not just on traffic safety. We might get it on, with what the age of licensing, for alcohol purchase should be, what the age at which teenagers can buy alcohol or whatever. There's always a lobby on something because there's somebody that loses often. But why news? I mean, I think newspaper owners just like stirring up trouble because that sells newspapers. It really does. Media owners, you can look at Fox News, you can talk a load of rubbish, actually harmful rubbish about issues, but millions of people will then subscribe to your service. And it's really hard to counteract them and use rational arguments. But most politicians are susceptible to, or many politicians are susceptible to rational arguments, at least the better ones. And then you can show maybe evidence from other countries. I mean, there was huge evidence from the UK on how roundabouts improve safety. I mean, roundabouts are really interesting. They weren't originally designed to improve safety. They were originally designed to, to cater to traffic flow. But people almost by chance discovered that they were a safety measure, and so on. So, and then the evidence built up. So, France copied the UK on that as part of the sort of, Jacques Chirac's road safety measures. They started adopting huge numbers of roundabouts. They probably have more than the UK now, and so on. So we can look to other countries. We can provide evidence. We have to try and keep the discussion on a rational basis. But I don't know of any way to stop the irrational from shouting.
Okay, great. Thank you. Well, yeah, we should close down, but I want to hear just one final advice from you, Oliver. You mentioned that, well, researchers do like writing papers, publishing papers.
Yep.
Yeah, that's what we kind of trained for. But I interpret your message that we also should go out and talk to politicians, to practitioners, talk to general public. So how would you summarize? I mean, what is the balance?
Well,
Should it be 80-20, 90-50-50?
Well, I'm more like 70-30 on advocacy writing papers at the moment. So, but that's not typical. The papers actually do help. I know Henk argued that politicians don't read papers, but if you can produce a paper that shows something and put it in the mailbox of a politician, they probably will read the abstract and the conclusions. So I think often because they don't have access to that literature, but if you personally hand them something and say, this actually deals with the problem that you're thinking about, and here's some evidence to consider, they do often pay attention. So I'm definitely not advocating that we shouldn't write serious papers, because it's really important that we write papers, that they get refereed properly, that we make sure that bad ideas don't get into circulation because there's no evidence to support them, and so on. I mean, we don't want people just, if you like, driving on intuition.
Mm-hmm. Great. Okay. Thank you very much, Oliver. Very interesting, very exciting talk. Thank you very much, the audience, for your questions. Yes. And I'm looking forward to see you again at the upcoming webinars. I don't have the official name yet, but we do have some good speakers in the pipeline. I promise you. So see you soon.
Okay, thank you very much, everybody. Bye.
Bye.